Alright, so I thought I would do a bit of a build video. If you download all the build files and decide to have your own circuit boards made and you want to build one of these on your own, this will take you through the whole process. I also may start offering this in kit form. I'll knock a few bucks off the price probably, but offer basically just a batch of parts that you can build up into your own board. If you like soldering and you like doing reflow work, it's a pretty straightforward build. So my collection of parts are what you see here. So there's a few standoffs, 16 buttons, the LCD display, the circuit board itself. This is the PIC chip, this is the FIDI serial interface, there's the USB socket, and then a few really tiny parts. A couple of 27 ohm resistors, a 10K, 1K, and a pair of 0.1K capacitors. That's it for the discrete components. So let's go ahead and just go through the build for this. Now, I am not the best builder on the planet by any stretch, but I have been able to make a bunch of circuits that work, and when they don't work, I can usually figure out pretty easily what's wrong and I can repair it. So I make mistakes, which is helpful for learning the process and so on. So there should be plenty of opportunities for learning here. So let me move some of the stuff out of the way. We don't need the push buttons for quite some time. And I'm going to initially concentrate on just these two surface mount devices. So first thing I'm going to do is just with some alcohol just clean the surface where I'm going to be making contact. These are relatively new PCBs, so I don't expect any oxidation, but it's just kind of a ritualistic thing to do. Alright, so these are very fine pitch devices. They're about 0.6 millimeters from pin to pin. I can solder them sometimes by hand, but it's a little challenging for me. So I'm gonna try these with solder paste. I have a template, but you wouldn't have that. So I'm just gonna go ahead and solder paste these. And let me do this under the microscope, just so that we can get a more close-up view of the process. So I'll begin with the PIC chip, and I'm just going to very kind of crudely, once I get this started. Oh, that was cruder than I wanted. Just kind of very crudely throw some paste down here on the contacts. Now this paste is a few years old, so it's not at its prime anymore, but I just put some down like that, put some down over here. I'll hit these. And I'm going to go back and clean this up, obviously. I'm also going to put some down out here just to get some initial contact between the metal parts of the USB socket and the board. And then I'll do the FIDI chip. Now these other components, would be pretty easy to do with solder paste, the capacitors and resistors, but they're also pretty easy to do by hand, so I'm going to leave them to go by hand. this off. Alright, so I'm going to do a slightly better job than I just did. So I'll just kind of smooth this out. This one actually looks pretty good. Smooth this one out a bit. And I'm just going to like get a fairly complete coverage on the pins. Now, this may look horrifying because, you know, I've got solder everywhere, but it's not too bad. I should have used less because I'm going to end up wasting some of this paste, but like I said, this paste is, I mean, it expired in 2022, so it's on borrowed time, and that's okay. But I don't need such a thick layer. Now, this pick chip, this is the one that I have the worst issues with as far as bridging between the pins. And on the bottom of the pins, if that bridges, it's pretty easy to clean up with enough flux. But if it flows up into the legs of the pins, that gets to be more problematic, at least for me. So that's the one I was most concerned with. This one I'm probably the least concerned with, and then the Thevideo chip seems pretty well behaved. So get rid of the stuff where I know I don't need it. I'll just leave this one as it is. And that's good enough. Let's do some soldering with some reflow. So going to place this, you know, pretty approximately where I want it. It's nice if you can see enough of your pins to know if you're lined up. That looks pretty good. And then this one, I'm going to come over here and just drop it down right about there. And then the USB socket, I'll go ahead and just drop that right in the middle here. Alright, there we go. Let's go ahead and hot air this. The main thing is you want pins connecting with pins, and then as the solder starts to flow, this will tend to self-align. So let's see how we go. Alright, so I was saying solder paste, you know, when you get it, it's got a heating and cooling curve that is specified for optimal reflow. And basically, you know, it heats up slowly, it gets to the point where it flows, and then it cools down. I will crudely approximate that by heating it at 100 Celsius for, I don't know, about 40 seconds or so. I forgot to pay attention to the time, but just kind of heating it up a little to begin with. It's actually pretty warm in the garage I'm working in right now. It's been in the 90s, so it's pretty toasty to begin with. But I'll do that for a little bit, and I've got 3 presets on this this heat gun. So that's the 100, and I'll raise it up to 200, and I'm going to do that for about 30 seconds. The date and timestamp on this video from the microscope is bogus. It stops the clock every time you turn it off, so it loses time. But I'm just using it for relative time increments, so I wanted to go out 30 seconds. So I'm going to get to about 25 seconds on the clock here. And then I'm going to bump it up to preset 3, which is 340 Celsius. So that's pretty hot. but it seems to work well. I don't know what the actual flow temperature is for this particular solder paste, but this has worked well for me, and I haven't really cooked too many devices by doing this. So this should start to flow pretty soon, and so I'm going to, I can see the pick chips solder is starting to change a little, so I'm going to keep the heat gun over on this side of the board, and I've been moving it over to the Thevideo chip also, but let's concentrate on the pick chip until that reflows. So you can see solder starting to melt. There we go. And yeah, I'm going to have a little bridging. I can see those upper two pins are bridged, but that's okay. Let's get this solder down here at the bottom. Alright. And then let's get the left side. I've almost got a solder bridge down here on the bottom right. We'll deal with that one too. But let's get the left side flowing. There we go. Nice flow, so that side's looking clean. Alright, we just bridged the pins down on the bottom there, no problem. I'm happy with that alignment. Let's go over to the rest of the USB socket. We'll let that flow. Get the solder up by the case, and now we'll come in for the Thevideo chip. And it looks like this side of the chip is a little too low, but I'm guessing that might self-align. We'll see what it does when the solder melts. So there it goes. We'll look for this side to jump up just a little bit. We'll have to get the top melted too. That's looking good. Alright, so that's a lot of bridging. But okay, we'll clean that up in a little bit. So let me clean this up a little. So I've got a variety of tools here. I've got some Q-tips. I've got these little polyester covered Q-tips. Well, that's really hard to see, but they work pretty well, and they don't have lint with them. So this board, of course, is still pretty hot, but I'm just going to clean it up a little bit here, see what we're working with. I'm going to saturate this in flux shortly, but I just kind of wanted to make sure that, you know, the pins are at least lined up and where they should be. And so yeah, I'd say that looks fine to me. So I'm going to go ahead and put the microscope back on top of the soldering mat. I'll put this in here and fire up the iron. And so our next task is to clean up these solder joints. Down here, there's definitely a bridge. There might be a little ball of solder right there. Definitely got some bridging there. The USB socket, I always look at separately because that seems extra hard to get connections made, but that's all bridged together, so we'll take those out. And then this one is just a whole bunch of solder where we don't want it. So let's go ahead and start doing some work on that. So this is similar to drag soldering. You can actually do this from the start. If you're trying to solder a chip, you can just use this technique, but like I say, I've had some issues with it, So this one, it looks like it's really just these pins up at the top. So let me start with that and see if I can just get that little piece of solder out. If not, I might have to do the whole side, but just putting a little solder on my iron, so I've got a wedge tip here, and I'm just going to put it down by the base of this chip and move up, and yeah, that's not working, so I'm going to move down, and you can see I'm kind of moving that blob with me, and I didn't put enough flux on here at the bottom, so let me put some more in here. And I'm keeping my iron fairly dry at this point because it will pick up solder from the pins. And I'm actually wiping it as I come off. So I've got 3 pins bridged now. And that's just about ready to go clean. Yeah, I need more flux though. This is kind of trippy because you can feel yourself playing with the liquid. The liquid, of course, is actually metal. Yeah, this one's stubborn though. Got just those 2 pins left. So there we go. So that's nice and clean on the right side. Let's see if we can make quicker work of the left. But I'll be generous with the flux this time. Now I'm greedy. I want to see if I can get it by moving the iron up instead of dragging it all the way across. But I don't know if that's going to work. Let's find out. Alright, how'd we do? I think that looks clean. Let's go ahead and work on the FIDI, and then we'll do the USB port separately. So this one, I definitely want a lot of flux. Not as much as I've got on my toothpick. These are bamboo toothpicks, by the way. I like them because they're pointy on the tip, but they've got a big, wide, round base, so they're easy to hold. Alright, I'm going to put a little solder on my iron for this because I'm going to do the whole side. So just a little dab of solder, and then I'm going to come in here and just pretend I'm drag soldering. And yeah, it's just that last little part. Alright, that looks good. And now on this other side, I've definitely got some blobs up here. And I'm just going to come down the whole side. almost got these last 2 pins. There we go. Alright, so that chip looks good to me. Let's go into the USB socket. Big dose. Now I like these USB sockets because, as far as I can tell, the back part here is isolated from the internals on the other side, so if you get over generous with the flux, it doesn't end up messing up the plug that you put in. Alright, and that I think looks really good. Last thing I want to do is just really get a big wallop of solder in these connecting points on the back so that the socket doesn't pull out and stress the contacts first time I plug something in. So I'm just going to put a bunch of flux in there. Now I'm going to get a really wet tip on my iron, and I'm just going to like press it in here for a few seconds. So I get this big like bulging dollop of solder. Do that on all 4. Good. Alright, turn off the iron for a while, turn off the scope for a while. Alright, now I want to clean this up. I'm not going to be too fancy right now. I'm just going to use a paper towel, get that flux off the back, and I'm just using lots of alcohol here, and a microscope too. And you know, I was shamefully generous with the flux, so this is a big mess. One of these days I may get an ultrasonic cleaner, but I don't know, it's not bad to clean these things by hand. Q-tips are also good for getting into spots in between components, and you know, this will leave some lint, but I'm not going to use Q-tips for the final cleaning. I'll switch to something lint-free for that, but just so I don't, you know, have to interact with a lot of flux while I'm working on the rest of the board, I want to do a surface clean here at least. So that's pretty good for now. At this point, you know, we're missing the capacitors and we're missing the buttons and the display, obviously. But we can do a fair amount of debugging already. So what I'm going to do is I'm going to go ahead and plug this thing into a USB port and watch the system messages and see if it resolves as a USB device. I'll plug it in both ways. That'll tell me if I've got all 4 of my connections set up well. And then I'm going to go ahead and I'm going to program the PIC chip. Now, if you're building this on your own, you'll have to deal with programming the PIC chip. And if you know how to do that, great. If not, that's going to be a learning curve. But using MPLAB, IDE, or IPE will let you do that. If you buy this in kit form, I'm going to send it out with pre-programmed PIC chips, so you won't have to do this. It'll already be programmed. You'll be ready for the next part, which is testing the display. But I'm going to switch to my other machine and run a few initial tests on this. Alright, so I can't test the USB connectivity yet because I didn't put in those 27 ohm resistors, but I can apply power to this through the USB port, presumably. And then I'm going to run mplab IPE. I'll do it from the command line. So I'll go ahead and run that. And come over to the operate. So I've got the PIC 18F27K42. I'm using a PIC kit 3. That's behind the desk, so you can't see that right now. And I'm going to connect to the PIC kit. And sometimes you get like voltage warnings, and I'm not sure what to do about those. I say ignore it, but you might want to actually read it and see what you're ignoring. Now the hex file, target device not found. Oh, okay, so I've got my 5 lines coming from the PIC programmer, and I'm just going to put them into the programming port, and I'm just going to apply a little pressure just to keep this connected, keep connectivity here. So let me go ahead and connect this chip again. And I'll say OK, and let's make sure it actually connects. Good, it found the device. It verified the device ID. So let me come over here and let me browse for a file. So I'm in PIC, Microprocessor X, distribution, default production, and there's a hex file in there. So I'll load that in, come back here to operate, and just say program. And that should go ahead and dump the program in. So this is saving me having to solder a header on the board and then leave it there, tempting people to change the firmware, which you want to do very cautiously, because as soon as you do that, it may no longer be FCC compliant. So proceed at your own risk. But we're just loading in the hex code that we know works, and like I say, if you buy this thing in kit form, the PIC chip is already programmed. Alright, programming verify complete. We are good to go with that. So next thing I want to do is see if it actually fires up. So you can go ahead and build your display, solder those pins on there. I haven't done that yet. This is a different one, but I'm going to just place this into the display socket, and again just put a little bit of pressure on it. I'm going to remove the power and plug it back in, and hey, it comes to life. You can't read what it says, but trust me, what it says is beautiful. It's got the whole display. I don't think we'll be able to zoom in. Nope. But it's got everything that we want there. Oh, but I lost contact. Let me do that again. Bring the display up, and if I drop this way down, you can see it's showing me the input port, the PC, the flags, the stack pointer, and so on and so forth. So so the PIC chip looks good, and it's programmed now. I don't have to do that again. It's actually connecting to the display. Let's go ahead and solder in those small components, and then we'll come back and we'll check to make sure that that the USB port is working correctly, and then we'll go ahead and do the buttons, and we should be done. Alright, so let's switch over to the better controlled flux. I like ridiculous amounts of flux for working with those surface mount parts, but I'm going to do a little more controlled exhibition here. So just a little dollop. This is still way more than we need. but way less than we might get with that other application method. And I've got a box of nice Kimtech wipes that are lint free and nice single sheets and so on, but for this stage of things I can get away with just using plain paper towels. So I'll put in the 0.1 microfarad capacitors. Now these are just despiking capacitors. So I think if you got them in the wrong spot, things would still work just as well. But try to keep them where they're supposed to be. So this is the 10 microfarad down at the bottom, and then the 1 microfarad goes next to the fee. That's the FTI 231, that's the serial interface. And then the resistors go up here. These are not the smallest components you can get, but they're about the smallest that I can work with comfortably. I think these are 06, 03. You can get down to 04, 02, and that's, I guess 50% smaller. So I don't need to challenge my eyes that much. Alright, so turn the iron back on. Let's come back to the microscope. And let's just line these pieces up. There's C4, there's C2, and then the 0.1 microfarad classic despiking. And then the tiny little resistors. Solder on here from when I was doing the rework on the chip next to it. But that's okay. Alright, I'm going to do the resistors first because they're going to be the easiest to disrupt, and they're kind of the hardest to place. So, good wet iron tip, and I'm just going to hold this right here and just dollop one end. There we go. And this one I'll hold and dollop. Good. And I'll get the other ends. That's good. And this one. That's good. Alright, now we do the caps. And I'll do all of these so that I don't have to worry about knocking them out of place. So I'll tack down one side. You don't want to accidentally come in contact with the pins on that PIC chip, because then you gotta start over again with cleaning up all the solder bridges. So now it's pretty easy. Those parts are set, and there we go. I'm going to do a little more cleanup on the flux, just because I'm going to take this back in to my desk so I can check the USB connection. And now with these resistors in place, we should be able to plug in the USB port, and the operating system should notice that and should resolve it as dev tty USB 1. And once that happens, we are good to go. And then we can go ahead, we can put on the buttons, we can do the display, and then we're done. So alright, let's let's see what we've got. Alright, so we're done with our programmer. Let's bring up a window. Let's do a dmessage wait, and let's plug this in. And we plug it in. Oh, that's not good. Alright, let's try flipping it over. We plug that in. That's not good either. So it's not finding the device correctly. It's noticing it, but there's a problem somewhere. So we gotta go back under the scope and see what's going on with this chip. Alright, so I'm just looking at this up close, and I'm seeing a lot of flux in between here. I don't think that should be a problem, but I'm a little suspicious. So I'm just going to go ahead and hot air this a little bit. No harm if it's not necessary. Let me turn this on. I don't know. I just want to reflow a little bit the pins on this chip and maybe the bottom of the USB socket. This happened to me once before, and I was never able to figure out what the problem was, but I was getting the same behavior when I plugged it in, and I actually wonder if maybe it damaged the USB chip. Maybe it's more heat sensitive than the PIC chip is. See where that gets us. Alright, so let's try this again. Let's do a dmessage W, and let's see what happens when we plug this in. And hey, it comes up as TTY USB 0, and I'm going to plug it in the other way, and same thing happens. So that's good news. After I did that reflow, I did find a bridge between two pins on the USB socket, so I think there was solder underneath that was shorting, and then when I tapped it with the tweezers, it squeezed it out, and I was able to unbridge that. So I'm going to say this board is good to go on to the next piece, which will be putting in the buttons. Now we can't actually test the buttons until everything is in place, because the buttons not only open and close circuits, but they also convey the signals in the 4x4 matrix. So we'll have to go for broke, put the buttons in, and then we can test it out. All right. Well, so I've got my 16 push buttons. I'm switching to a broader set of tweezers, and for this one, I'm going to try to use my more precise flux deposition. Now this works really well if you use solder paste and a template, because you get almost no cleanup work that you have to do at the end. But I'm assuming you don't have a template for exactly this printed circuit board. So let's go through the manual process. And even with that, it's not too bad. Like I say, the sort of most time intensive part is really just the cleanup at the end. And sometimes I do these in sets of 8, just so that I'm not like stepping on top of loose buttons and bumping them around and so on and so forth. You've already seen me do that a little. So I'm just gonna kind of eyeball these into place, and I'll do a few of these under the microscope, but I can actually tack down one of these pins just by eye. Because fortunately my eyes are still good enough for that. I missed 2 pins over here. This flux, by the way, I don't know, it came from Amazon, had a lot of good reviews, although a lot of people complained because it does this kind of action, right? So the plunger theoretically should fit into that piece right there, but it doesn't. And so you can't back it out, but you can push it in, and it doesn't seem to bleed too exuberantly when you do that. Alright, so let me bring this way back and let me start a recording and get some focus and just show you how this goes. So very wet iron, and I'm just going to hold this button in place and just tap one of the corners, and then hold this button in place, tap one of the corners. So I can almost always get 2 buttons out of a wet tip. I could probably get more sometimes, but I tend to refresh every 2. And I'm just doing this enough that I can then start soldering without having to hold it with tweezers. And I mean, these things will make contact wherever they end up. But you know, if they end up crooked, it's pretty obvious because they've got those nice square edges and they're all lined up with each other. So try to place them a little carefully. And I don't know how quickly this flux dries, and I don't even know if that's a problem if it dries, but I'll do all of these before I go on to the other side. And at this point, sometimes I'll actually take the solder out of the spool and just hold it in one hand. Just to make this a little quicker. And I've totally lost track of where I was, that's okay. This one you don't want to accidentally melt the buttons there below you. I could flip it over and be extra safe, but this should work out. Until we clean it up, it's actually a little hard for me, at least visually, to tell if I missed any of these legs. But once we clean up the flux, it'll be pretty obvious. Alright, so there's half of our buttons. And then we just repeat the process for these other 8. These are a little quicker because they're in a nice set of 4 columns. Place the buttons. Like so. And I can solder these without the microscope. And then use the microscope later to make sure nothing went wrong. But you can see the solder flow and flow up onto the leg of the button. And then once I've got those upper right legs tacked down, I can freely solder the other legs without having to hold the button. And that goes faster. Alright, so now I can two-handed the solder. So now I'm going to keep tacking down these other sides. And yeah, with enough light, this is pretty straightforward. It does help getting the buttons lined up though, because if they're a bit off, sometimes the legs just don't have a lot of contact with the pad. And that makes it a little harder to get a nice connection. Alright, so let's take a look at that in the scope, keeping in mind there's tons of flux on here. But let's see how this looks. So good, 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 good. 7, 6, 4, 5, 2, 1, 0. Okay, I'm going to say that's all good. So let's just make our display. So the display, when you when you put the pins into the display, they stick out a fair amount. That's okay. I prefer not to have that, so I'm going to just kind of push down on the plastic part while keeping those pins on the metal base of the microscope stand so that they end up just flush with the top of the board. And then I'm going to might be a little too much. Yeah, we'll give it a try. I'm going to put a little flux on here. Round one needs a little more soldering because it's usually a heat suck. So I'm going to do it just offline. Should have gone for the sloppier flux. But anyway, there's a good connection. And so now we are ready to test the board again. So I'm going to put the display in there and just kind of hold it up a little. And plug in the USB. And the display comes up, and I can hit most of the buttons. There's the display mode, there's the deposit button, there's the examine button, there's the step button, there's the run halt, program load, reset, and interrupts harder to check. So everything is working except my buttons 0, 3, and 6 aren't doing anything. So that left column, again, these buttons share a connection with each other. It's a cross matrix, so we have wires going this way and wires going that way, and the buttons transmit those signals. So one of the buttons that is feeding the signal over to this leftmost column is not completely connected. So I'm going to go ahead and clean this up, and then we'll take a look at it and figure out which connection is missing. When I'm doing this alcohol work, I'm trying to be a little careful about not getting alcohol above the buttons, because I got a lot of residual flux flowing around here, and if I get flux on a napkin or a Q-tip, and then I get that above the buttons themselves. Some of that flux might run down with alcohol into the button. The alcohol dries, the flux remains, and your buttons end up sticking as a result. And then you gotta swap the button out. We don't want to do that. Alright, so this will need a lot more cleanup before it's good to go, but let's just look at this and see if we can find what's missing connection-wise. So that 4 looked a little suspicious to me, but it's actually good. That's okay. Connected. So let me get a little bit of a poking probe. That's fine. That's fine. That is not making contact. And that probably comes down and goes across to feed one of the pins. So let's just put a little dollop of flux on there. And a little bit of solder. Let's go back and make sure that connects. Now if I plug my display in, and I plug in the power, I can do a 0, I can do a 3, I can do a 6. So all my buttons are working. This is a weak test because, you know, if the display loses connectivity, it will not come back always right away. But while you're debugging, sometimes if you hit the reset button, you can get it to come back. Sometimes not. Sometimes you have to just disconnect and reconnect. And then there's your display. Alright, so this is good to go. The buttons are working. The chip is working. The next thing I would want to test is the program load. And that will tell me, I know I'm getting USB connectivity through the serial port, but can I actually upload data? In other words, is the serial port chip connected properly to the PIC chip? So I would try using the upload command and just see if that works for a short program. So that would be the next test. You don't need to watch me clean up this whole board because it's a pretty unsophisticated process, but I'll come back once that's done. Alright, so cleanup looks pretty good. I am going to go ahead and use preferred flux, which is this UV80. I don't know what that means, but I like it. And I'm just going to reshape these little dollops on top where I connected the pins because they're actually a little pokey. But with that flux, they come out nice and round and smooth. So clean that up. Put some flux on the bottom here. And then when I put the display in, I actually like to angle it so that it's sort of facing towards the person pressing the buttons. So I'm just going to bend that first leg in and then sort of manually try to bring the other legs to where they'd have the standard 1/10 of an inch spacing. That in there, and so it's going to sit about like that instead of being flush. The last thing I want to do is try to keep these pins from being pokey underneath, because you know, if you're holding this in your hand. So I'm going to, you know, hold it where it's supposed to be and then cut the excess off of these legs. You can do this with a shield if you're sophisticated. I'm just going to close my eyes and let these fly into the wall. And at some point, I'll vacuum them up. Now I'm going to put a little solder on each of these. Do it. Last flux cleanup. Now, if this was a board I was building for shipping to a customer, I would have used solder paste and a template so I wouldn't have all of this flux to clean up, and I'd have nice clean connections, very little chance of all of that bridging that I had and having to reflow and things like that. But if you're doing this as a DIY, I'm guessing you're probably going to end up doing a lot of the soldering by hand, so I wanted to like show you that process. So we can plug this in once more and verify that it still does what it's supposed to do. So I'll plug it in, it comes up, I can get the display modes, examine, deposit, step, halt, program load, reset, 1, 0, 1, 2, 3, 4, 5, 6, 7. That all looks good. Last thing to do is put the mounting hardware on. So these legs have a polarity to them. One side is totally flat, one side has a little indent in it. I put the indent towards the board so that the part touching the ground or your hand is the one that's totally flat. I don't even know if these are necessary. If this is truly going to be handheld, you don't really need the little legs for it to stand on. But if you want to put it on the table, it's nice to have a nice even footing instead of, you know, dealing with a few solder bumps on one side and so on. So we'll put those on, and then we'll go back into back to my desk and just check the program load button, make sure that that is actually getting a good signal from the serial port, and then we're all done. I'm going to clean this board up more later, but it's getting late, so this is clean enough that I can use it for now inside, and then I'll come back and get rid of the rest of the flux later. So let's go inside and see how we did. Alright, so let's see how we did. So I'm going to come over here, and I have a hex file here, which is an octal file. I'm just going to say upload adder.bin. I'm going to plug this in and try to do a program upload. Now, USB maximum length that it's supposed to work for is something like 2 or 3 feet. I've got a 6 or 10 foot extension cord here, so this is pushing the spec, but we should be okay because this is going at 9600 baud, and usually if it doesn't work right away, after a few tries it starts to work. So we just want to know if there is connectivity here between the systems. So let's do program upload, and I'll do my upload command over here. Did not work. Let's try it again. And hey, there we go. Good upload. Let's go ahead and reset and run. This should add up the numbers 0 through 10, give me 67 octal 55. That's good. Last test. Let's plug this in the other way and repeat that exercise. So get ready to do an upload. Let's do a program load and run that. That still worked. Run the program, see if we get our 67 octal. That should be fine. Alright, good to go. Last test. I know that was supposed to be the last. I'll hold the button down while I boot, and that lets me load a program in. So I'm going to press a 3, which will load in a dice program. I'll run this, and when I hit the interrupt button, we should see the display briefly go to 376, 77. The stack pointer should bump up, and eventually it should show me two numbers between 1 and 6 over here on the output. So let me do that. That went to 376. My stack pointer is 2. Here comes the output register, and there it is, 2 and 2. So my point is 4. And if I press the interrupt button again, see I jumped up to 376 briefly, and it will roll the dice again. I'll get a new number, and there's a 4, so I made my point and I won that round. So it's showing me double 7s for winner. So yeah, this looks good. Alright, so here's the final board, all built, tested, debugged, and cleaned up. It's all good to go. We've got our push buttons for input and control and observation of the system. There's the LCD display, our 2 main chips, some supporting discrete components, the USB port. There's the back looking pretty clean. You can put your name down here. It's got the programming key. This is lucky serial number 13. It's got the mounting hardware down there to rest squarely. And if you plug it in, you won't be able to read the display because of the focus, but it powers up and there's the display, and we can run it, and it's changing locations and executing instructions and all of that stuff. So that was a fairly long build process, kind of on purpose, right? So I wanted to go through some of the things you might run into if you were building this by hand on your own. And getting things like solder bridges, or the mysterious missing connection on this reset pin that knocked out this column. To me, that's part of the fun of doing this, right? If I just wanted the boards, I could have the PCB manufacturer also do the assembly for me, and I'd get a box of assembled boards. To me, that would take away a lot of the fun of doing this whole project. So if you think you might be inclined to this, definitely, if you want to have the PCB built yourself, download the files, order some parts, have a go at it. If you think you might be interested in a kit form of this, drop me a note in the comments, let me know, and I might make that available on the stores. But anyway, that was a complete build from a pile of parts to a finished working touch metal board. Thanks for watching. Hope you have a good one. Talk to you all later. Bye.